Alright, this is the solutions for the midterm review for Precal 1, winter 2019. Alright, let's just get started. Number 1. A rectangular city park has a jogging loop that goes along the length, width, and diagonal of the park. To the nearest yard, find the length of the jogging loop if the length of the park is 125 yards and its width is 75 yards. So, if you want to think about it, we're looking at a rectangular city park that goes along the length, width, and the diagonal of the park. So, they're saying, I'm drawing red here, it goes along diagonal, a length, and a width. So it makes a triangle, in other words, right? Like this red triangle here. And it says that the length of the park is 125 yards, right? And its height, or width here, is 75 yards. So then what is the length of the jogging loop? Well, we need to know the length of the hypotenuse first. So let's go ahead and find that. So D would be the square root of 125 squared plus 75 squared. This is just applying Pythagorean theorem, right? And so you'd get, actually I'm not going to use an equal sign here. Let's use an approximately 145 point, and so let's see, let's look back at the question. It said to the nearest yard, so round to the nearest whole number. So if we round to the nearest whole number, this actually rounds to 146. So it's approximately 146 yards to go along this. So then, the length of the jogging track would just be 146 yards plus 75 yards plus the 125 yards for a grand total of 346 yards. Alright? Alright, number 2. Let's switch back to normal black ink here. So number 2, let's find the distance between these 2 points. So let's just recall that the distance formula is x1 minus x2 squared plus y1 minus y2 squared. Assuming you're given points x1, y1, and x2, y2, right? So then our distance in this problem is the square root of 6 minus 2 squared plus negative 4 minus negative 2 squared. So that's the square root of 4 squared plus double negative there, that becomes a plus, so negative 4 plus 2 is negative 2 squared. And so that's the square root of 16 plus 4, which is 20. And you can leave it as square root of 20. There's nothing wrong with that. You could simplify the answer, thinking about it as square root of 4 times square root of 5. That's 2 root 5. Or, in all honesty, you could just pop it in your calculator also and give me an approximation there. The instructions don't say, you know, to leave it rounded to anything or leave it in exact form, etc. So if you were to put it in your calculator, 2 squared of 5 is approximately 4.472. I'll go out to 3 decimal places. You could round to whatever there. On the exam, I actually did tell you to leave it however you feel. So, number 3 says, find the slope of the line containing these 2 points. So recall that slope is just y2 minus y1 over x2 minus x1. So, using these points, I got 5 minus 0 over 0 minus 2, which is 5 over negative 2. Or you could write negative 5 halves, or negative, no, that's fine. Negative 5 halves is more than sufficient solution, that's fine. Okay, so negative 5 halves. Number 4 says graph the line containing the point P and having slope M. Alright, so number 4 here. If you have slope and you have a point that's not the y-intercept, it's pretty easy because there's point slope formula, right? Assuming you have a point x1, y1 and the slope M. So we do. So y minus the y coordinate of 0 equals negative 4 thirds times x minus 4. So this becomes y equals negative 4 thirds x plus 16 thirds. Alright, so now that we have this in y equals mx plus b, or slope-intercept form, this is pretty easy to graph, right? If we had a nice graph here, so I don't know, I'll go up, let's say I'll go by 2. So 2, 4, 6, 8, 10, 12, 14, 16, alright? And we'll do the same thing in the x's here. So 2, 4, 6, 8, 10, and you get the gist. All right. I'm only drawing the positive ones because we really only need that in terms of the way our graph is defined. So if we rewrite it, negative 4/3 x plus 16/3. So plus 16/3, that's roughly about 5 1/3. So somewhere like here-ish. I am just sketching this. But we know that the exact point is 0, 16/3. That's the same thing, like I said, as 0 and 5 1/3. So, like I said, roughly about halfway between the 4 and the 6 tick mark there. A little bit above because of the 5 1/3. And then what's the slope tell us? Negative 4/3 says for every 1 you go to the right, or 3 you go to the right, you go down 4. So if you go over 3, you go down 4. So something like that, right? Over 3, down 4, give or take. Is that down 4? No, I don't think so. That's only down 2. So then over 3, so 1, 2, 3, down 4. 1, 2, 3, 4-ish. Something like that. And there we go. 2 points is enough to graph a line, is that right? And there you go. It'd be nice to label the points that you have, or at least show the steps as to how you got them there. Okay, number 5. So number 5 here says, the average value of a certain type of automobile was $13,200 in 1991 and depreciated to $9,900 in 1994. Let Y be the average value of the automobile in the year X, where X equals 0 represents 1991. So if X is 1, then it represents the year 1992, etc. So write a linear equation that relates the average value of the automobile Y to the year X. So, in essence, since they tell us it's a linear equation, that means just take the 2 points we have, find the slope, and then do typical point-slope formula, right? Or slope-intercept, if we have that ability. So 1991 is represented by x equals 0. So we have 0, $13,200 as a point. And we also have 1994, it was $9,900. And 1994 would be 3 years after 1991. So x would be 3, and the value there was $9,900. So we have 2 points. Let's find the slope of the line that goes through these 2 points. So remember, y2 minus y1 over x2 minus x1. So we've got 13,200 minus 9,900 over 0 minus 3, excuse me, over 0 minus 3. So this comes out to, let's see, is this a nice number? 13,200 minus 9,900 is 3,300. Divided by negative 3 boils down to negative 1,100. And oddly enough, right, since we have the slope, take note that we have 0 comma something. 0 comma something is the y-intercept, right? So we have the slope, we have the y-intercept, then we can just write it in y equals mx plus b form, or in other words, slope-intercept form, right? Y equals negative 1,100x plus 13,200. Or if we use the variables that they have in the problem, oh wait, no, I did use the variable, sorry. I used x and y. So there you are. There's the linear equation that relates the average value of the automobile in y to the year x. Okay. Number 6, similar type problem. Says an investment is worth $2,423 in 1995. By 1999, it has grown to $2,919. Let y be the value of the investment in the year x, where x equals 0 represents 1995. Write a linear equation that relates the value of the investment y to the year x. So, same as the exact same as the last problem, only the numbers are different, right? So, let's write our 2 points that we have. So we have 0, 2423. And then we have that in 1999, so 4 years later, it is worth $29.19. It went up in value. It appreciated. Let y be the value of the investment in the year x. Write a linear equation. All right, so again, let's find the slope. So 2423 minus 2919 over 0 minus 4. So 2423 minus 2919 is negative 496. Divided by 0 minus 4 is negative 4. And so when you divide by negative 4, that reduces to 124. So there's the slope. And again, check it out. There's the y-intercept, there's the slope, so we just put it in y equals mx plus b form. y equals 124x plus 2423. And we are done. Number 7. Each month, a beauty salon gives X manicures for $12 per manicure. The cost to the owner of the beauty salon for each manicure is $7.35. The monthly fixed cost to maintain a manicure station is $120. Write an equation that relates the monthly profit in dollars to the number of manicures given each month. Then use the equation to find the monthly profit when 200 manicures are given in a month. So first things first, let's recall that to find a profit function, you need to know the revenue function and you need to know the cost function. Profit is revenue minus cost. Now let's go see if we have these two items. So revenue, this comes up pretty early on, right? It says that each month the beauty salon gives X manicures for $12 per manicure. We do have the revenue function. It's $12 per manicure, per being times, and then X being the number of manicures. So we have the revenue function. And now do we have the cost function? Well, yeah. It says that the cost of the owner of the beauty salon for each manicure is $7.35. So $7.35 per manicure, right? Plus, there's a monthly fixed cost to run the station period, so it costs $120 just to even open up, right? So then what does the profit function look like? Profit is just revenue minus cost, as we have written above. So profit equals revenue minus the cost function. So let's fill this in. Revenue is 12x minus the cost function is 735x plus 120. And so this comes out to 465x minus 120. When you distribute that minus sign there, right? 12x minus 735x, 7.35x is 4.65. And then that minus sign distributes to the 120. And so our profit function is given by 4.65x minus 120. And so that gives us the function. Now let's use this to model when 200 manicures are given in a month. So we want to know what's the profit when 200 manicures are done. So profit at 200 would be 4.65 times 200. What was it, minus 120? That's right, minus 120. So pop that into your calculator. 4.65 times 200 is actually 930 minus 120, which is 810. So $810 in profit when 200 manicures are done in a month. All right, number 8 says, write the equation in slope-intercept form. In other words, write it in y equals mx plus b form. So just solve for y. So 12x plus 5y equals 8. Subtract 12x from both sides, and you get 5y equals negative 12x plus 8. Divide both sides by 5, and you get y equals negative 12/5 x plus 8/5. And you can tell me immediately, what's the y-intercept? 8/5. What's the slope? Negative 12/5. And there you go. Number 9. Alright, so number 9 says a truck rental company rents a moving truck one day by charging $25 plus 9 cents per mile. Write a linear equation that relates the cost C in dollars for renting the truck to the number of X miles driven. What is the cost of renting the truck if the truck is driven 200 miles? Alright, so this is much simpler than the last problem. It's just a cost function problem. The cost is $25 fixed plus 9 cents per mile, right? 0.09 times X. There's your linear equation. It's the fixed cost plus the variable rate, which is 9 cents per mile, where miles are given in X. So what's the cost of renting the truck if the truck's driven 200 miles? Well, that's C of 200. So 25 plus 0.09 times 200, which is 25 plus 18, or $43 if we want to label this correctly. All right. Number 10. Find an equation for the line with the given properties. So if it's to be parallel to the line y equals 2x, that means parallel tells us that they have the same slope. And there's the slope, it's 2. So, our slope needs to be 2. And it needs to have the point 8, 8. If you have a point and a slope, well, we have a formula for that. Y minus y1 equals m times x minus x1. That's y minus 8 equals 2 times x minus 8. And you could box the answer right there. Typically, we all prefer to have it solved for y because then you can put it in a calculator and graph it or more easily manipulate it, right? So let's go ahead and do that. So y minus 8 equals, distributing the 2, 2x minus 16. And so y equals 2x minus 8 when you add 8 to both sides there. All right. Number 11 is very similar, only rather than it being parallel, that you want it to be perpendicular to a line. All right, so number 11 here, let's go ahead and take this equation that they gave us and solve it for y so that we can find the, so we have negative 5y equals negative x plus 3. And then dividing both sides by negative 5, we get y equals 1/5 x minus 3/5. So the key thing here, we don't even care what the rest of this equation is, it's 1/5. So the slope of the line that's given here is 1/5, right? So I'll call it M1 for now. The slope of the line we want, though, is supposed to be perpendicular to this. And so remember that perpendicular lines share this property. They are negative reciprocals of each other in terms of the way that they're defined. So then the slope that we want then is negative 1 over 1/5, which is negative 5. All right, so the slope we need is negative 5, and we need it to go through the point 5, 3. So then, negative 5, and it's going through 5, 3. So then, y minus y1 equals m times x minus x1. Typical point slope formula, right? So y minus 3 equals negative 5 times x minus 5. So y minus 3 equals negative 5x plus 25. Y equals negative 5x plus 28 when you solve for y explicitly. And there's our solution. Number 12. So number 12 here says the solid line L contains the point 2, 4 and is perpendicular to the dotted line whose equation is y equals 2x. Give the equation of the line L in slope-intercept form. So they want us to write it in y equals mx plus b form. So this is actually pretty simple. We got the point 2, 4 and they give us the equation of that line. It's 2x. So that tells us that the slope of that line is 2. So the slope of the line that we want then is negative 1 over that slope, which is 2. So negative 1/2. So y minus 4 equals negative 1/2 times x minus 2. Again, point slope formula. And then solve for y. So we got negative 1/2 x plus 1. So y equals negative 1/2 x plus 5. And there you are. Number 13. So number 13 says perpendicular to the line y, x equals 6 containing the point 5, 3. Alright, so the first thing to remember is that a line x equals 6 is literally a vertical line x equals 6. Okay? So then something that's perpendicular to that will just be y equals some constant number because it'll be horizontal, right? Instead of being vertical. And we want it to be going through the point 5, 3, so then we know what the y coordinate needs to be. It needs to be 3. So y equals 3. That's it. That's just all there is to it. That's kind of making sure you know that knowledge. Obviously I'm not going to give you a test question that's just that simple, but do you understand that, a perpendicular line to a vertical line is horizontal, and vice versa. The perpendicular line to a horizontal is a vertical line. Okay, so number 14. Number 14 says find the center and radius r of the circle and then graph it. And they give us the circle in general expanded form here, right? So let's go ahead and complete the square on all this stuff. So x squared minus 6x, leave a little space, plus y squared minus 10y, leave a little space, equals negative 30. And so we're going to add two things here, right? You take that middle term, so negative 6 cut in half is negative 3, and negative 3 squared is what? 9. Alright, so that's just kind of me doing some scratch work here. I'm adding 9 to both sides there. I'm going to go ahead and erase this scratch work, okay? So that I can do it again for the y's now. So you take half of that middle term, so negative 10 cut in half is negative 5, and negative 5 squared is 25. So I'm going to add 25 to both sides there. Okay, so again, I'm going to go ahead and erase this work, this scratch work. So that now we can take note. When factoring as a trinomial, these things are perfect squares, right? X minus 3 squared plus y minus 5 squared equals 4. Or if you want to, you can think of this as 2 squared. So that, what's the center of this circle then? 3 comma 5. And what's the radius of this circle? 2. The radius is 2. Alright, so now we can graph it. Center, 3 comma 5 with r equal 2 radius, right? So we got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 3 comma 5. Alright, that's the center. So go up 2, right 2, down 2, and left 2, right? And there is our circle. Okay. Okay, number 15 says, the projectile was thrown upward so that its distance above the ground after t seconds is given by h of t equals negative 11 t squared plus 396t. After how many seconds does it reach its maximum height? Well, let's think about this. This is a parabola. Parabolas open up or down based off of that lead coefficient. It's a negative, so that tells us that this thing, whatever its shape looks something like this, right? It opens down. Now I know for a fact that it goes through the origin. Why? Well, look at this thing. It has t's everywhere. If you plug in 0, what do you get? 0 squared is 0. 0 times anything is 0. Plus 0 times 396 is also 0. So you get 0. So it looks like this. So in other words, all I'm looking for is the maximum is, where's the vertex? I'm looking for the vertex, right? So remember that happens, the x-coordinate is negative b over 2a. Or sorry, in this case, it's actually not the x-coordinate. It's going to be called the what? The t-coordinate. And so that's a is negative 11, b is 396. So negative 396 over 2 times negative 11. And so dividing this out, you should get, let's see, what is that? The negative 396 divided by negative 22 is 18. So it happens 18 seconds into it, right? And that answers the question. After how many seconds does it reach its maximum height? Well, 18 seconds. If they wanted to know what the maximum height was, well, how would you find that? Well, you just plug 18 into the function, right? And there you go. So number 16. The number of mosquitoes, M of x in millions in a certain area, depends on the June rainfall, x in inches, given by M of x equals 17 minus x squared. What rainfall produces the maximum number of mosquitoes? So again, this is just like the last question, only let's put it in standard form first. So negative x squared plus 17x, or in normal descending order, right? And that way you can go, oh, right, a is negative 1, b is 17. So this is just literally, again, a same question as number 15. Find the vertex, right? So x equals negative b over 2a, or in other words, negative 17 over 2 times negative 1, which is just 17 halves, or 8 and a half. And what does that 8 and a half represent? 8 and a half inches of rain. So what rainfall produces the maximum number of mosquitoes? 8 and a half inches of rain evidently produces the maximum number of mosquitoes. Number 17 says, simplify the expression. Assume that all variables are positive when they appear. Alright, so just that kind of typical question of testing your knowledge on, do you know your conjugate pairs, right? Rationalize the denominator is the typical instructions for this. It says simplify the expression, but in all honesty, the proper instruction should be rationalize the denominator. And the way to do that is to just multiply by, like I said, the conjugate pair of the denominator. So since the bottom is square root of 5 plus 2, you can multiply by square root of 5 minus 2. And that creates a difference of squares pair in the bottom. The top is easy. Let's go ahead and distribute. Root 3 times root 5 is root 15. Root 3 times negative 2, that's negative 2 root 3, all over, and the denominator, the square root of 5 squared minus 2 squared. Again, just using the difference of squares formula, right? So then this is root 15 minus 2 root 3 all over 5 minus 4. And 5 minus 4 is just 1. So this is just root 15 minus 2 root 3. Okay? Number 18 is actually easier. 5 over root 7. When it's just a plain Jane radical, it's actually really easy to rationalize the denominator. You just multiply by the radical itself. The top is 5 root 7. The bottom, root 7 times root 7 is the same thing as root 49, or just 7, right? And that's it. 5 root 7 over 7. Number 19 says determine which values, if any, must be excluded from the domain of the variable in the expression. So in other words, just find the domain of this thing. What are the values that can't be included in the domain? So let's just find the domain of this. It's a rational function. 8x minus 5 over x squared minus 81. That's a division of polynomials. And polynomials have domain all real numbers by default. But you can't divide by what? 0. So let's find out when the bottom is 0. That's difference of squares if you want to think about it that way, or you could just move the 81 across also, and then take the square root of both sides. So x equals plus or minus, because when you take a square root, plus or minus, right? 9. So then, plus or minus 9 are the 2 points that couldn't be included in the domain. So to actually answer the question the way it's worded, determine which values, if any, must be included from the domain of the variable in the expression, plus or minus 9. If we wanted to actually write what is the domain of this function, it would be what? The set of all real numbers such that x isn't plus or minus 9. And there you go. You could also do it in interval notation, but I'm good. I've written it right here for you. Number 20. Same question again, right? And this is again a rational function. And so just determine when the denominator is 0. But this is a sum of squares. If you try to solve this, you move 64 across, you get negative 64. And if you try the same method we did last time, taking the square root of both sides, you take the square root of a negative number, and that's not real. That's a complex number, right? And so we only worry about real valued functions, so there's nothing that we have to exclude. So what is the domain? So again, to actually answer the question, it says which values must be excluded. Well, no values must be excluded, right? Because what is the domain then? The domain is literally all real numbers. You could use R instead of all x, such that x is a real number. And that's not, it's almost silly to write that. So it's like, yeah, just write it. It's all real numbers. 21. Perform the indicated operations and simplify the result. Leave the answer in factored form. So these are compound fractions, aren't they? 4 plus 2 over x, all over x over 3 plus 1/6. So what I typically do with this kind of problem is I just clear all the denominators. So like in the bottom, what could I multiply by to get rid of both a 3 and a 6? Well, we'd multiply by a 6. And in the top, how do I get rid of that x? Well, multiply by x, right? And so up top, we distribute that. That's 6x times 4 is 24x, plus the x's cancel in the second half right here, right? And 2 times 6 is just 12. Over. Now in the bottom, that 6 over 3 is just a 2. And then x times x is x squared, plus the 1/6 times 6 cancels out, leaving just the x. And so let's go ahead and factor this bad boy out and see if anything simplifies worse. Check out the top. They're both factors of, or multiples of 12, leaving 2x plus 1. And on the bottom, they both have an x. So factor an x out, leaving 2x plus 1. And guess what? What cancels out? 2x plus 1 over 2x plus 1, leaving just 12 over x. All right. Number 22. Number 22 just says solve by factoring. So x squared minus x equals 72. The first problem is that to factor, you should have what on the right-hand side? You should have a 0. So go ahead and move everything to one side, and this makes life a little easier. We're looking for two numbers that when multiplied equal negative 72, but when they add up to negative 1. And so if you think about this, that's clearly negative 9 and 8. Negative 9 times 8 is negative 72, and negative 9 plus 8 is negative 1. So x minus 8 times, x minus 9 times x plus 8 equals 0, giving us 9 and negative 8 as our solutions. 23, again, just solve by factoring. 5x squared plus 7x minus 6. Again, when the lead coefficient isn't a 1, you do 5 times negative 6. You do the first coefficient times the last coefficient, and then you do the same process as the last time. A times b, looking for two numbers that multiply to give me negative 30, but add up to give us 7. And so, again, should look like 10 times negative 3. 10 times negative 3 is negative 30, and 10 minus 3 is 7. So this time, rather than using those numbers to actually factor it, you use it to break up that middle term. 7x is the same thing as 10x minus 3x. Okay? And then you just factor by grouping. In the first two terms, what factors out? Both a 5 and an x, leaving x plus 2. And out of the second two terms, those are both a negative number, and they both are divisible by 3. So if you factor out a negative 3, you're left with x plus 2. And oh, surprise, surprise, what's inside the parentheses on both of these? X plus 2. So if you factor that out, you're left with 5x minus 3. So 5x minus 3. So we get x equals negative 2 from this first one. And if you solve 5x minus 3 equals 0, you get x equals 3/5. So our two solutions are negative 2 and 3/5. 24. 24, solve the equation by completing the square. And I gave you something fairly straightforward, and you've technically already done something on the test that requires you to complete the square. That was putting a circle's general form into standard form, right? But just kind of a reminder here, just in case you've forgotten the process again. You take the middle number, cut it in half. 4 divided by 2 is 2. Take that number and square it, which is 4. And that's what you're going to add to both sides. Add 4. Now the whole point is that the side on the left over here should look like a perfect square when you try to factor it. And it is. It's x plus 2 times x plus 2. Or in other words, x plus 2 squared equals 3 plus 4 is 7. Well, now that everything's squared, you can just take the square root of both sides. Don't forget your plus or minus. So x plus 2 equals plus or minus the square root of 7. And last step, subtract 2 from both sides to get negative 2 plus or minus the square root of 7. And there you go. 25. We're on the home stretch here. Last 4 problems. So the manager of a coffee shop has one type of coffee that sells for $5 per pound and another type that sells for $14 per pound. The manager wishes to mix 100 pounds of the $14 coffee to get a mixture that will sell for $9 a pound. How many pounds of the $5 coffee should be used? This is just one of these proper mixing problems, right? Let's just create 2 variables of our own, and then we can keep going, right? So has a $5 per pound coffee and a $14 per pound coffee. So let's make the $5 per pound coffee X. That's how much of it, right? Amount of $5 per pound coffee. And let's make Y be the amount of $14 per pound coffee. Okay? But they want to mix these two things together to get 100 pounds. Oh wait, the manager wishes to mix 100 pounds of the $14 coffee to get a mixture that will sell for $9 per pound. How much of the $5 coffee should be used? Alright, so then, just kidding, we don't even need this variable, right? We know how much it's going to be. It's 100 pounds. So let's just use my typical little VAT diagram to do this. You got $5 per pound coffee. We don't know how much of that we're going to use. Plus 100 pounds of this $14 coffee to get 100 plus X pounds of $9 per pound coffee. Alright. You multiply these numbers vertically and it turns into the equation you need. 5 times X plus 100 times 14 is 1400 equals 9 times 100 plus X. So 5X plus 1400 equals 900 plus 9X. And then you take 5X from both sides. Alright, subtract 900 from both sides. And you get 500 equals 4x. And divide both sides by 4 to finally get x equals 125 pounds. So you need to use 125 pounds of this $5 per pound coffee to mix with 100 pounds of $14 per pound coffee to get a coffee that would be equivalently $9 per pound. So 125 pounds if we're going to label properly, all right? And there you go. 26. The manager of a candy shop sells chocolate-covered peanuts for $9 per pound and chocolate-covered cashews for $14 per pound. The manager wishes to mix 80 pounds of the cashews to get a cashew peanut mixture that will sell for $13 per pound. How many pounds of peanuts should be used? So this is the same kind of, it's a mixture problem, right? I think the question I did in class that was similar to these in terms of the notes was some like an orange juice or like an antifreeze type of question, like a pure something needs to be mixed with another beverage or something like that. If you're trying to look back at your notes. So anyhow, similar picture. We have a couple of vats being mixed together of stuff. So we're going to mix together a $9 per pound chocolate covered cashew. Yeah, these are the peanuts. Sorry, the $14 per pound cashews. We want to mix them together with these peanuts. So peanuts, cashews, and this will be a mixture over here, right? That they sell for $13 per pound. Okay. How many pounds of peanuts should be used? So this is what we don't know. And we're going to mix 80 pounds of cashews to get 80 plus x pounds of this mixture. So again, multiply vertically. 9x plus 14 times 80. 14 times 80 is, what is that? 0, 2, carry your 3, 11, 20. Plus, oh, not plus, whoa. Equals, excuse me, equals 13 times 80 plus x. So we got 9x plus 1120 equals 80 times 13 is 1040 plus 13x. Subtract 9x from both sides. Subtract 1040 from both sides. And so you get 4x equals 80. Divided by 4 on both sides, you get x equals 20. So 20 pounds of this $9 per pound peanuts needs to be mixed with this 80 pounds of $14 per pound cashews to get a $13 per pound mixture. Evidently 100 pounds with this $13 per pound mixture. All right, so question 27, just an absolute value and inequality. So we got absolute value of x plus 8 minus 2 needs to be less than or equal to 5. So absolute value of x minus 8 needs to be less than or equal to 7. So picture-wise, that says it has to be somewhere between negative 7 and 7, right? So how do we say that algebraically? Well, x plus 8 needs to be somewhere between 7 and negative 7, right? Negative 7 is less than or equal to x plus 8. It's less than or equal to 7. Subtract 8 from everywhere. Negative 15 is less than or equal to x, less than or equal to negative 1. And so, solution set is a set of all x such that negative 15 is less than or equal to x is less than or equal to negative 1. Or, like I said, or at least as it says in the instructions, you could also do negative 15, negative 1, close brackets to indicate interval notation, right? It does specifically say express your answer in interval notation. So that's what I boxed is the technically correct answer based on what the question actually asks you. Last piece, absolute value of 5 minus 7x needs to be greater than 9. So similar picture, here's negative 9, here's 9. To be farther than 9 units away means that you need to be to the right of 9 or to the left of negative 9, but 9 and negative 9 themselves aren't included because it's not less than or equal to or greater than or equal to. It's just a strict inequality. So let's go ahead and write these out. It's 5 minus 7x needs to be less than negative 9, or 5 minus 7x needs to be greater than 9. So let's go ahead and just solve these. Subtract negative 5. So you got negative 7x needs to be less than negative 14, or negative 7x is greater than 4. divide both sides by -7. And remember, when you divide by a negative number, you need to remember to flip the inequality sign. So less than over here becomes greater than. This greater than over here becomes a less than. So this is x is now greater than 2, or x is less than -4/7. So to write that in interval notation, that is -infinity up to -4/7, soft parentheses or open parentheses, union 2 to infinity. And so there it is in interval notation, or again, the set of all x that are real numbers such that x is less than -4/7 or x is greater than 2. Okay? That's the end of the review. Good luck studying. If you have other questions, feel free to email me, y'all.